Alrighty, hello everybody, welcome to another electronics video. In this one in particular, we're going to cover different types of DC motors. I'm going to be making 3 videos on DC motors, so this is part 1 where we're going to cover types, brushless versus brush motors. The second one, we're going to cover electrical characteristics, and in the third one, we're going to talk about control. Okay, so let's get into types. So I'm going to be frank. I am not the best at explaining motor mechanics, but I'm going to do my best. I highly recommend that you do some research by yourself online if you're interested in this. But I'm going to do my best with the materials I have. Okay, so we say DC motors, right? So let's first talk about what DC means. So what is DC electricity, right? So there's 2 main types of electricity. One is DC, which is direct current, and AC, which is alternating current, right? And the thing with DC is that within DC current, electricity only flows in one direction, right? You have a steady 12 volts or 5 volts of voltage. That's direct current. Alternating current on the other hand, right? It goes positive and negative, positive and negative. It keeps on flipping around. And as you can see with the blue line, it's kind of like a sinusoidal wave of voltage. Right? And a source of direct current would be our batteries, right? So the batteries we use at robotics are these 12 volt DC batteries. And a source of alternating current would be, for example, your wall outlets. I think in the United States we have 110 or 120 volt AC coming out of our wall. And if you go to European countries, it'll be 220 volt AC. Okay, so now that we know what DC electricity is, we can talk a little bit about motors, right? So how do motors work, right? We apply a DC voltage into a motor, and somehow it makes the axle spin, right? So how does that work? Well, I don't have any actual magnets or electromagnets to demonstrate this, but I do got pencils and sticky notes, so I'm going to try to make do with this, okay? So the basic principle behind how motors work is to change the polarity of an electromagnet, right? The way to do that is by changing the direction current flows in an electromagnet. So say I have current flowing in one direction, then north would be here and south would be here. But if I flip the direction current flows, then I can flip the polarity of the magnet so that south for the electromagnet is here now and north is here. Right? And if we introduce a permanent magnet, a stationary permanent magnet, right? We can create rotation in the electromagnet. Right? This is how we do it. So say that we start the motor like this, right? And we know like poles repel, so north and north repel. So this electromagnet is going to spin like this, right? Now south and north are exactly where it wants to be, and it'll stop, right? But in order to keep the rotation going, what we're going to do is we're going to flip the polarity of this electromagnet. So we flip it, okay? And now north and north are back together, so it's going to rotate. Flip, rotate, flip, rotate, right? It's going to keep on doing this over and over again, and we've accomplished kind of rotational motion from a voltage application to this electromagnet, okay? So that's generally how DC motors work. And the way we accomplish this changing electromagnet is what varies between the 2 types, our brushed and brushless motors, right? So let's talk about that, right? So let's first talk about what brushed motors are. So these are the 3 examples of brush motors we use at FRC. This first one here is a Vex Pro motor, brush motor. I think we would call it a 775 Vex Pro motor. And these ones are really good for intaking situations, low power applications, right? For example, like intake. This we use it in our intake mechanism, our hopper mechanism. Really lightweight motors, really good for low power applications. Right. The one right here is a bag motor, and this one right here is called a sim. And we used to use these mini sims and sim motors for high power applications like the drivetrain. But as you'll see later on, we've kind of shifted to different motors other than these sim motors. Okay, so these are 3 types of brush motors we have in FRC, and there are a lot more. Okay, so how do brush motors work? So remember I talked about how for a DC motor to work, we have to figure out how to alternate that electromagnet so that it keeps spinning, right? And the way brush motors accomplish this is through a commutator and a set of brushes, right? So let's first talk about the other elements, right? We have the stator magnet, which is the surrounding shell, which is our permanent magnet. So this is the rotating one. The stator is this permanent stationary magnet called the stator magnets. Okay. The rotor coils are a series of electromagnets that is represented by this one right here, right? This moving electromagnet. And the commutator and the brushes is a mechanism it uses to modulate the direction of current in the coils, right? So this commutator spins, and depending on its orientation, it will send a current in the electromagnets of varying direction and polarity. Okay, and the brushes are what supply voltage to the commutators, right? So this brown thing right here are the brushes, and these copper strips are the commutators, right? And so to summarize this, brush motors accomplish a changing electromagnet by using the rotation of the commutator and different orientations to supply changing current. I hope that makes sense, right? And YouTube has much better explanations. I'll link some videos. So I recommend you watch that. But it's cool if you don't want to. All right, so those are brush motors. Okay, so now we have brushless motors, which is the second type. All right, these are 3 examples of brushless motors in FRC. All right, so this one right here, the one on the left, is called the Neo 550. It's this really itty bitty cute motor. We were going to use it this year for our control panel mechanism. It's really good for kind of lightweight, where you need lower power and lightweight uses. So that's the Neo 550. This one in the middle is kind of our workhorse for this year, which is our Falcon 500. It is a brushless motor. And the cool thing with this one is it has a motor controller attached to it. We'll talk about electronic controllers a little later. But this one is a very powerful motor. I think it's about, I'm not a mechanical guy, so I don't exactly know for sure. But I think it has about the same power as a mini sim or a sim. And so, yeah, that's the Falcon 500. And this one on the right is the Neo, also a very powerful motor, and it's pretty lightweight as well, like the Falcon 500. Okay, so there are 3 main types of brushless motors in FRC. Let's get into the anatomy, right? So again, forgive me, my explanation isn't going to be as great as I would hope, but I'm going to give it a shot, okay? So instead of using the brushes and the commutators in physical contact like the brush motors do, brushless motors, or BLDCs, they use an electronic controller to modulate the current in the electromagnets. Right. So this is an example of an in-runner BLDC. There's two types of brushless DC motors. Ones are in-runners, where the inner axle in the motor spins, and outrunners is where the entire shell of the brushless motor spins. Right. So if you go back to our three here, right, the Neo 550 is an outrunner, meaning the entire shell of the brushless motor spins, and the Neo and the Falcon 500 are in-runners, where the axle spins. Okay, so this is the diagram of the in-runner BLDC, because that's the most I found that as the most common type. Okay, so for in-runner BLDCs, right, we have a series of coils, these coils right here, surrounding an inner permanent magnet, and this permanent magnet is attached to our shaft. Okay, and so an electronic controller is plugged in along with the BLDC, and it properly times and activates the coils with the correct polarity depending on the orientation of the shaft. And the way it detects the orientation of the shaft is using something called a Hall effect sensor. Hall effect sensor is a magnetic sensor. You don't really need to worry about how that works, but just know that it uses a Hall effect sensor to detect the orientation of the shaft. Okay. Again, right, so it's using the electronic controller to properly time and properly orient the electromagnets so that we achieve motion, right? Instead of using our brushes and commutator from our brush motors. Okay. All right, so now I'm going to talk about some advantages and disadvantages with brushed and brushless motors. All right. So the first advantage is that for brush motors, is that it can run directly off of DC power. Right? For example, say Build just made a shooter and they want you to test a prototype shooter and they want you to test it, right? With brush motors, we literally can just take a battery and some power modulator and plug it directly into the brush motor and it'll work just fine, right? With brushless motors, you need that extra controller for it to run. So brush motor is simpler to run directly off of DC power. Simpler electronics, right? So this is not exactly true with the Falcon 500 because it has the controller attached onto the motor. But for motors like the Neo 550 and the Neo, right, electronics becomes a little more difficult because instead of just the two power wires coming out of brush motors, right, we have to handle the Hall effect sensor and the three-phase power coming into the brushless motor, right? So with brush motors, simpler electronics. Okay, and overall it's cheaper compared to its brushless counterparts, right? This is because we don't have to pay for that sensor and the integrated controller, right? So it's relatively cheaper compared to brushless motors. Okay, disadvantages, it is a little less efficient. So brush motors operate from 70 to 80% efficiency usually, which is a little less than brushless motors, right? And because of the general mechanics of brush motors, it creates a lot of electromagnetic noise, right? And this electromagnetic noise can kind of hinder with sensitive electronics around those brush motors. And an example of this, we'll talk about this later when we talk about routers and Ethernet, right? But when we position our router and a radio, which we consider a sensitive piece of electronics, we try to keep it far away from motors because the EM noise it creates can kind of hinder and interfere with the signal coming out of the robot. Right. Another disadvantage is that the brushes wear out over time. Remember, our brushes are making physical contact with the commutator, and just like anything that's constantly rubbing, it's going to wear out over time. And this makes brush motors slightly less reliable and slightly more maintenance for brush motors. Okay, under brushless motors. Right? So brushless motors, advantage is because, again, we don't have those brushes, there's no physical contact, it's more reliable and you have less maintenance going on. And it's a little more efficient, right? So remember, brush motors were 70 to 80% efficient. Brushless motors are 80 to 90% efficient. So this means it's gonna convert more of the power input into rotational motion rather than heat, right? So a little more efficient. Some disadvantages: it is higher cost. Remember, we have to pay for the sensor and the required controller, so it's a little higher cost compared to the brush motors. And we have more complex electronics, right? So going back to the example where Build wants you to test a prototype, right? We can't just plug it in directly into DC power. We have to have that separate controller and plug it into the controller and plug it into our computer to control it, right? And so we know we need this extra pieces of electronics in order to operate our motor, unlike our brush motors. Okay, so those are advantages and disadvantages. We're going to wrap up with an example problem, right? So example problem is, what type of motor would you use for intaking a ball and why? And what about for shooting a ball? Okay, give you a few seconds to pause. All right, so for intaking, all right, we're going to use our brush motor, and here's some reasons, right? So it's usually intake mechanisms, at least from my experience in the past 3 years, they're usually not weight sensitive. So having a slightly heavier brush motor is okay. No problem in that. Lower efficiency is okay, right? Intake is usually not a very high performance application. So if we have a slightly lower efficiency, it's all right, and we can save some money by using a brush motor. And it's easily replaceable, right? Again, in my experience in the past 3 years, those intake motors are much easily replaced than, say, a drive motor, which you need to do all that gearbox mess. Again, I'm not a mechanical person, so don't take my word on it. But I feel like intake motors are more easily replaced, and thus a brush motor makes more sense. All right, how about for a shooter, right? So a shooter, I would go the brushless motor. And this is because shooters are very high performance and high stress environments, right? We're constantly ramping up and down the shooter. And just to clarify, the shooter I'm talking about is a fast rotating flywheel. Okay. And so in a flywheel, right, it's a very high performance, high stress environment. We want our motor to provide the most power output for the voltage we provide it, and that's done by our brushless motor. And it's reliable, right? We want to have we don't want to have to replace the shooter motor very frequently, right? And it needs to be able to handle that high stress environment. So the reliable brushless motor is the way to go. Alright, so that's it for this video. The next video we're going to talk about the next video is going to be about electrical characteristics. So I'll see you then.